Well, morning, everyone. I think we should start with the webinar. Well, thank you all for attending and for joining us for this event, and also a big thanks to the speakers we have today for this webinar. I'll just offer a very brief introduction, and then I'll leave the floor to my colleagues to talk about a number of open source technologies that we think can play a key role in developing and building Europe's next generation edge cloud. Well, first of all, the program we have for today, as I said, big thanks to all my colleagues that were able to make it this early in the morning. If this was a physical event, we would have free coffee, tea, even if those nice mini croissants, but I guess we'll have to use our imagination. What we're going to have is really interesting talks anyway. And I'm sure each of these presentations are going to be really inspiring, and I'm going to help all of you to discover or probably rediscover a number of technologies and how each of these projects and companies are adapting to the new edge computing paradigm as it evolves and becomes a reality in Europe. So that is the program for today. We'll be using like around 10 minutes per presentation, with 5 minutes for questions and answers after each presentation. So feel free during the talks just to use the chat. So if you write down your questions on the chat, you send them to us, to the panelists, then each speaker will go through the questions at the end of the presentations. And we'll finish around 10:30. Well, my name is Alberto. I'm the VP of Open Source Community Relations at OpenNebula. Those are my contact details. I'm normally based in Spain, but these days I have to come to Italy. So if my connection fails at some point, that's because I'm in a tiny village in the middle of the mountains. But hopefully everything will go fine. So very quickly, quick review of why we put this webinar together, why we think it was the right time to talk about edge computing, and to talk about edge computing from an open source perspective, and more specifically from a European open source perspective. So as most of you already know, I'm sure, edge computing is becoming a thing. It's not a buzzword anymore. For a number of years, we've heard conversations, and we've all read this news and about edge computing. What we see this year, I think we all agree, it's going to be a turning point in the way edge computing is actually becoming technology that's being available for a number of companies, and it's going to actually be disruptive in different ways. And there are a number of projects that are developing technologies, and as we'll see in a second, and adapting their technologies to edge computing and this new paradigm. And also there are a number of initiatives from public institutions, and mainly from the European Commission, for instance, to support the way in which Europe becomes a leader in this market. I think it was important for us as European open source projects to come together and say, look, we are working on this as well, and we are planning to support these initiatives. So why edge computing? You are probably more than familiar with the many benefits that it provides. We're talking about deploying ultra-low latency applications, improving user experience when you bring services and applications closer to your end users and customers. We're talking about expanding service availability. Instead of having a centralized cloud, we have more infrastructure and resources for services to be more reliant to possible incidents. We are reducing data transfers and security risks involved in moving data from one place to another. Well, in that sense, we're minimizing as well vendor dependency, or avoiding some vendor lock-ins when you have a larger number of providers available for you to move your workload from one place to another. We are talking also about reducing energy consumption in terms of moving data and applications and services around. And also an important aspect of edge computing will be to be able to foster a new local and ecosystem of cloud and edge providers across Europe. And that's something that's, as Jules will mention in a second, has already been identified as one of the main objectives or targets for Europe's digital transformation. In that sense, personally, I think it's been really inspiring how the European Commission has been taking a very bold approach to edge computing and developing Europe's capabilities in that sense, and also in their explicit support for an open source approach to these new technologies, edge computing and other cutting edge technologies. And as you know, many of you are really involved in different initiatives. One of them is Gaia-X. We are members of Gaia-X, for instance, and I know several of you are really corporate members of Gaia-X, and that's a project we all look forward to help and contribute to. The European Commission published the Digital Compass a few weeks ago, identifying this specific target for deploying by 2030 10,000 edge nodes across the continent. I think that's going to be also a major boost for investment, but also for technological development in Europe in terms of supporting how these nodes are going to operate and interact with each other. And obviously, that's one of the main objectives for today's session, is to bring some technologies closer to different companies and organizations that are involved in the IPSA for Cloud and Infrastructure Services project that's currently being developed, led by Germany and the German and French government, along with a number of other EU member states, which I mean, we all agree it's also going to be a major initiative in this area. Why we put this webinar together, as I said, as open source companies and projects and with strong European roots, I think we all agree it's the right time to start. I mean, discussing about how edge computing is going to influence our way to develop our technologies, and to look for ways to collaborate as we all approach the challenge of adapting our technologies and also our business models sometimes to this new technology, new paradigm. In that sense, being able to collaborate to develop what's been identified as one of the main challenges, which is having some platforms for, and specifically open source platforms, to address the needs across this cloud edge continuum, or across the data center edge continuum, actually. So to be able to move workloads and operate and manage your applications and services across the whole continuum of infrastructure, from your corporate data center to the far edge. There are lots of opportunities here, and as we develop these collaborations focused on a number of European open source technologies we're going to be discussing today, but also requiring other actors to get involved, integrators and research organizations, a number of cloud providers and current and future edge providers in Europe, manufacturers and 5G providers and the telecom sector in general. They have a lot to say in how edge computing is going to unfold in the continent. And also public investment, also private investment is going to be important in this sense, to build this new ecosystem around open source technologies and providers in relevant use cases for key industrial sectors in Europe, being able to mobilize all the research and development and innovation in Europe and investment capacities to create these opportunities, open up new business cases and spaces for collaboration among competitors as well. And that's also one of the benefits of taking an open source approach. So that's all from my side. Well, big thanks to the European Commission for their support to the ONEedge project. This is the umbrella we're using for this webinar. And I'll leave you with our first speaker. Feel free to take over, Daniel.
Yes, good morning, everybody. Give me a second. So, good morning. I'm Rahn. I'm a product manager at SUSE, located in Nuremberg. And today I have the opportunity to talk to you about our newest product in our product portfolio called SUSE Linux Enterprise Micro. So we'll keep it short and pregnant, talking about the product as an overview and about the life cycle, and then give you the opportunity to ask questions. When we look at the SUSE product portfolio itself, of course, we are well known with our enterprise products, and SUSE Linux Enterprise Micro is the newest addition to our product family here. A key feature and benefit of all the products that we are creating in our SUSE Linux Enterprise family, actually, give me a second. Is the common code base. So basically we have one source code in our infrastructure, and depending on the product and use case, we have the ability to flexibly create binary packages from one common code base throughout our product family. As you can see, we have a couple of architectures that we provide. So we take a very holistic approach on where our products are supported and then can be run. And we also cover a big area of deployment areas here, desktop, data center, cloud, branch, and specifically for this session here, also the edge. For SUSE Linux Enterprise Micro, we've taken advantage of our technology that we have in-house, also our build service, and combined our established enterprise code base into a new product that is really focused on edge deployments. So the product has seen its birth end of March this year. And when designing the product and defining it, we focus really on the 4 pillars that you can see here. And I'll start from the right to the left. So the priority for us here really was focus on containers for a very specific reason, because our approach at Edge is really the operating system should not be of a concern to the end user, to the customer, to the guys implementing the solution here. So all workloads are supposed to be run within containers. So that's why we have designed SLI Micro as a container host OS. It starts as a container host OS that supports running non-Kubernetes workloads, and then by adding K3s, which Gerald will be talking about later in this webinar, we then cover the Kubernetes world of things. So really an operating system fine-tuned, optimized really for container workloads. At the same time, we do realize that there are certain workloads that may not be able to run in containers just yet. So we also support running virtual machines based on the KVM technology on SUSE Linux Enterprise Micro. We've taken an additional approach here coming from the SUSE Linux Enterprise code base to really support developers with SUSE Linux Enterprise Micro, specifically in that we define SLI Micro as a very adaptable operating system, meaning we don't have any thresholds, any borders, any safeguards in there. So developers are, and the customers are really free to fine-tune their deployed images or deployment images of SLI Micro, really focused on the use case. So we do support customers to fine-tune their deployments. So SLI Micro specifically is not meant to be an off-the-shelf product. So our expectation and our vision for SLI Micro is really that customers fine-tune the deployments of SLI Micro, customize it really down to their use case, and that way have the optimal solution to power their workloads in the edge. When we're looking at our SUSE Linux Enterprise product portfolio, of course, SUSE Linux Enterprise Server is well known in the market, and it's more well known for the mission critical features. With SUSE Linux Enterprise Micro, we turn that around a bit. So mission critical is still a theme and a topic for SUSE Linux Enterprise Micro, but our focus here is not mission critical, but zero maintenance. So really our vision for SUSE Linux Enterprise Micro is that the operating system maintenance and administration is at a bare minimum that is required. The operating system itself has self-healing functionality built in. So it will recover from most of the expected issues that may happen itself without any requirement for administrators to really intervene and access the system. And in addition to that, we've also designed the product with the support of very long service life cycles in mind. So we're thinking about up to 15 to 20 years for a specific release to really cover the use cases and demands of customers. The key feature, however, of SLE Micro, and that's the name Micro here, is that it's designed to be a very small, very minimal, tiny footprint operating system. At the same time, enterprise class of reliability. SLE Micro itself is an immutable operating system, so it runs from a read-only root file system. Therefore, it does run the same artifacts as every time it is booted, reliably and repeatedly. And it is optimized from our point of view for OEM workloads and specifically edge and industrial IoT. So that's really the focus for SUSE Linux Enterprise Micro. As you see here, we've launched the first version 5.0 in March and are going to extend it with every version that we release. Brief summary, here really an immutable OS, read-only file system with a minimized operating system footprint that also helps you decrease the attack surface. So you have a really small attack vector with regards to the operating system. Manageability, as I said, we focus on very minimal requirements here. So once deployed, the administrative overhead is close to zero. It supports easy mass deployment by supporting image-based deployment as a priority and is very customized for partners and customers here. So we don't have any requirements for a certain set of software that is deployed when you install it. The biggest benefit here, however, for SLE Micro is that it inherits the hardware and software certification of SUSE Linux Enterprise Server. So by using the advantages of the common code base, we are able to provide a new operating system, providing new technology and new functionality to customers, and at the same time preserving hardware and software compatibility. So therefore minimizing the required investment to take this product into production. When we look at the lifecycle of SLE Micro, then we've also decided to do things a bit different here with SLE Micro than we are doing it with SUSE Linux Enterprise Server. SLE Micro is on a release cycle that has a release every 6 months. We are doing that specifically to foster the innovation and then providing the ability to really provide new features and advantages and enhancements to customers in a very Loctite life cycle here. So you see that the first release was released end of Q1 this year. The next release, 5.1, we are currently already developing on, and that's supposed to be released end of Q3 this year. And that scheme will continue. Every second release will be used to rebase to the newest SUSE Linux Enterprise common code base, and the version in between will really be packed with additional features for our customers to exploit. Looking at the life cycle of the version itself, so the initial release was kind of a limited support release that is limited to 1 year of general support. Starting with a 5.1 release in September this year, we will be providing up to 4 years of general support for each version. That provides really peace of mind for customers going to SUSE Linux Enterprise Micro because they will receive up to 4 years of updates, security fixes, and support from us. So their workloads are really safe here, and you can run your edge deployments in a supported way. This is what I prepared for you today, and Now you have the opportunity to ask questions.
Well, Daniel, I had a question for you, actually.
Go ahead.
I see. I mean, you've been supporting ARM, the ARM architecture from the beginning, right? And so
yes. So SliMicro supports two architectures actually compared to the enterprise family. So we support 64-bit Intel AMD, and we support 64-bit ARM.
Mm-hmm.
Yeah, and there's actually one interesting fact here on the Intel part. We actually provide the choice of either using the default SLES kernel or using a real-time kernel. The real-time kernel is currently not available on 64-bit ARM, but we are working on providing that with a later release. Mm-hmm. So this is really the focus of SliMicro, providing choice to the customer.
Mm-hmm. Okay. I think you've got a comment in the chat, but the yes, there's some offering to collaborate.
Yeah, and Ivo, yes, I'll take a note and I'll reach out to you.
Okay. Well, one of the things, Daniel, you guys have had some conversations with IoT manufacturers in terms of how to turn their devices. We've identified, for instance, some interest in some manufacturers also to be able to turn their IoT devices into small infrastructure. I mean, offer those infrastructure resources or small, tiny infrastructure resources to third parties, to customers as well. I don't know if that's also a plan you are considering for Enterprise Micro to be able to in some way turn those IoT devices into infrastructure resources, small infrastructure resources for customers.
Yes, yeah, naturally, Alberto. I mean that is really the future that we are looking at quite naturally, and we are talking with our hardware partners, and we have interesting in-depth discussions and actually concrete plans with some of them to provide offerings here to the market. And but the one thing I have to say is that. What SliMicro really is the base operating system. So SliMicro really covers a lot more than tiny IoT devices. It also goes into the industrial edge area where we really have a lot of projects running at the moment. So it's very interesting and very exciting to see edge really taking over the landscape.
Mm-hmm. In all different dimensions, right? Because that's
yes.
The challenge to be able to across that continuum to be able to offer something. Yeah, that's also something we agree on. Yeah. Okay, well, thank you very much, Daniel. Again, if there's any question at any point, just for attendees, just write out on the chat, and we'll take them at the end, or each of the speakers will be able to contact you and answer your questions. Well, thank you, Daniel. Thanks a lot.
You're welcome.
Philipp, the floor is yours.
Hello, here's Philipp Reisner speaking. So before I dive into my topic, let me lose a few words about the company. So LINBIT is an organization of a little above 30 people. Most of us are working out of Austria, and we have a smaller office on the west coast of the United States. So that is LINBIT, and we have like exclusive distributor for Japan, that's the SUSE group, and working in other areas of the world with partners. So what are we doing? We are providing a software-defined storage. So that is a software that organizes the storage devices in a number of machines and make that a highly available provider for persistent volumes. And that relates to edge deployments. as edge deployment might be only a small number of machines, and you might have the requirement to have reliable storage there. So when does it fit? It fits when you need persistent volumes for containers like Kubernetes, Nomad, Docker. It is a very good fit when you need persistent volumes for virtualization environments like OpenNebula, our hosts here. But we also have drivers from OpenStack. The Apache Cloud Stack driver is in preparation. XCP-ng is also in preparation. Proxmox VE, that is ready as well. Apart from the orchestration technology, for what kinds of application is it a good fit? And it is really a good fit when you have applications that are demanding for I/O. So like online transaction processing, databases, and maybe even message queuing systems. And also for analytics workloads, where you have these workloads that create a lot of read requests, and then the whole data set is exchanged. Our focus is to deliver a storage software that delivers high performance, and do that with low overhead. So again, that makes it a very suitable fit for edge deployments, since there you have limited resources and you want to take as much output as possible from the limited hardware you have available there. So how are we doing that? Most part of our data path, well, all of the data path, that is in kernel. So one aspect is we rely on many building blocks that are available on the kernel and maintain our own replication engine, that is DAVD. So that's one of those pillows we build on. Then the layout of volumes onto different servers, that is done at allocation time. And the advantage of that is that during I/O, so when time is critical, everything is known, and we have a fast data path. Here we are building on existing components, and that is not only to save some work for us, but it also helps your day 2 operation, because in case anything goes wrong, in case anything needs to examine, debugged, your operation team will work with a lot of existing components, and the software-defined storage is not a black box, maybe even a proprietary black box we cannot log in. So building on these building blocks has advantages in multiple layers. And as well, a direct implication of all this is that this SDS is very well suited to be used in a hyperconverged way. And again, something what is very well suited for edge deployments, because you want to reduce the number of servers you have in these edge locations. So maybe the cluster is as small as 2 nodes. And why that? Because it is it doesn't consume a lot of resources. So it doesn't consume a lot of CPU cycles, and it doesn't consume a lot of your DRAM. So it's really, really minimalistic on that. And when you know the storage size, you can upfront know how much DRAM it will consume. So there are no surprises in operation of this technology. And in a sense, so this is really the 10 minutes pitch of it. What is it doing? So it is managing your cluster and allocating persistent storage on the storage device. Well, it allocates volumes on the storage devices, gives you persistent volumes out of that. So it manages clusters from 3 to thousands of nodes with some limitations. You can also go down to a 2-node cluster. Supports multiple storage tiers, multi-tenancy or QoS for the storage workloads, and you can have complex allocation policies that considers how the storage allocations should be distributed among your chassis, racks, rooms, etc. How is data made persistent? Well, we always have to live with the possibility of hardware failure or machine failures. So data needs to be replicated in order to be persistent. It does synchronous, asynchronous, 2 or more copies of your data, consistency groups, and here it really goes into the details. It might help you with selecting the right paths over the network if that is necessary in that environment. And business continuity features. So apart from the replication you might use within the site, you might decide to do async replication to an offset location. But it can also do backup to S3 storage, and then it does that in an incremental manner. So have full backups and incrementals out of that. Yes, so that is basically what I want to tell you in these 10 minutes. So a few more things. So when it comes to the integration to the workload orchestrators, we might find in edge deployments. So as mentioned, we have OpenNebula, the integration, but also to Kubernetes. So the full spectrum of technologies that is necessary there, the CSI driver that gives you the principal connectivity to Kubernetes, the operator to roll out the storage software easily, the Stork scheduler extension that gives the Kubernetes scheduler the necessary insight to do good scheduling decisions regarding to the storage, high availability for the storage software itself and for the workload. So for stateful sets in a context of Kubernetes, and nice integration with kubectl plugin. And maybe one word about the business model. So all this is open source software, as mentioned, and we deliver it like in 2 flavors to the consumers. One is the complete open source packaging that is called an Piraeus data store. So you find that on the public registries and can use it from there. And we also have a commercial packaging of it that is delivered to customers, comes with support and certifications where certifications apply. But in the end, you get the things built from the same source code. That's like the overview. It covers you from detecting the hardware all the way up, delivering all the storage features, replication, encryption, address, deduplication, caching, and delivers it somehow to the workload. Okay, that was like the 10-minute version of it. And now I'm hoping for some questions.
Thanks, Philipp. I think we are all very strict today with the timing. Well, I had a question for you about the comparison between LINBIT and obviously and Ceph and Portworx and so kind of solutions that have been there's been some attempts to use them at the edge environments. They're going to be at some point. But
yeah, thanks for the question. When we compare it to Ceph, and it seems like Ceph became like the dominant storage technology in the open source world. Ceph will consume a lot more resources. So, you know, you have to dedicate multiple cores just to the storage software. And then also its DRAM footprint is not predetermined. You know, you don't know it upfront how much DRAM it will consume. So that all things, that doesn't make it a perfect fit when you want to co-locate it with your workload. And so in that regard, I think our software is really ahead of the game. On the other side, Ceph brings you like object storage and Cephfs as well. We only do a block storage. And you also mentioned Portworx, I think. Portworx is a proprietary player in the field, delivering software-defined storage for Kubernetes only. And let's put it that way, its architecture is pretty similar. Our stuff is open source and performs extremely well.
So it sounds, I mean, from your perspective, I mean, from a technological perspective, I mean, adapting your technology to edge computing is not going to involve such a massive disruption, right? Of the way you've been designing your solution, right? So it's
yes. So from the requirements that were driving us in the past, I would say what we do is already a good fit for the edge case. You know? And we also have it ready for x86, for ARM64, Power and C, and we are just waiting until RISC-V becomes available that we can make it available on that platform as well.
There's a question there on the chat. I guess it's I take it it's a general question to all of us, but I think Philipp, if you want to give your answer to that.
Okay, I'm reading the question. To what extent OS open source solutions can completely avoid lock-in and full portability, and where instead can exist troubles? Where to start? I would say with nearly everything we do here in the open source world, there is no vendor lock-in because by definition, what we do is open source. If you're not lucky with the one vendor supporting you right now, take another vendor, take it to your consulting company of choice and let them support you. And also, I think we don't create proprietary formats since this is not in our DNA. So this is the best I can answer this question. If anyone else from the panelists want to jump in, go ahead.
Yep, if anyone else wants to, I have my own opinion about this, but I'll leave you give yours. Okay.
I think there was the question also about what else can go wrong, and I would say cloud is the what else that can go wrong. So even if there's no lock-in when it comes to an open source solution, there might be lock-in de facto by being married to one single cloud provider.
But then you married yourself to the API of this cloud provider, right?
Yes.
Well, I mean, that's the whole idea behind Gaia-X, right? So to be able to create some kind of abstraction layer on top of a number of cloud providers as well.
Indeed.
So, I mean, Philipp, we'll talk about edge computing, but in terms of large deployments? I mean, how is LINBIT performing in that sense?
Yeah. So the
I mean, we also get the same question sometimes, but how big is your biggest deployment?
Yes, so we have a CSP here in Europe, a cloud service provider that is currently running LINBIT STS on 620 nodes, and he's extremely happy about it. And you might know it, they also run OpenNebula.
Okay. Yeah, I mean, one of the challenges of edge computing obviously will be to be able to manage things at scale. So maybe not centralized somewhere, but at least being able to manage all these resources in many different locations in a kind of distributed edge cloud. Okay. Well, thank you. Thanks a lot, Philipp, for the introduction and for your time. Kai, all yours.
Okay, excellent. My name is Kai Arnö. I'm the CEO of the MariaDB Foundation, and I will be the young rebel today, not sharing any screens, but instead looking straight into the camera and say a couple of basic things about MariaDB, and of course from an EdgeEU free and open source software perspective. So MariaDB is the fastest growing open source relational database management system. And that's a mouthful. What that means, I'd like to position it against what it is not. So it's relational, meaning it's not a NoSQL, it's not MongoDB. That's how it differs from MongoDB. Yes, it's also somehow open source, MongoDB, but that's not relational. Then it is open source, so it's not Oracle. It is free software with all the benefits that everyone here expects it to have, and then some, because there are interpretations of what open source is. There are ways, there are flavors of how to implement it, not as much just between the different licenses, but also between the development models. If you have an open development model or one where you just dump your results at certain intervals. So it does belong then to a category where there are other relational open source databases. And the two notable ones would be Postgres and MySQL. So it's not Postgres in the sense that it has a different licensing model. MariaDB is based on the GPL version 2 license, quite like MySQL is. And there's BSD when it comes to Postgres. And the consequence thereof is that with Postgres, you have a lot of closed source extensions because of the true freedom, or true, it sounds like a positive word. It's meant to be a neutral word in my sense here. You can do anything you wish with a BSD code base, meaning you can extend it with 5% of added value and claim all of it as your own, as a closed source solution, which means that there is a proliferation of more versions, if you will, based on Postgres. And that's not the case with software that is based on GPL version 2, because any extension to it also needs to be GPL version 2. And that's what it has in common with MySQL. What it doesn't have in common with MySQL is, of course, the ownership. So we're talking about vendor locking here. MySQL is nowadays owned by, well, since 10 years, owned by Oracle, which puts a certain impression on how the further development of the product is being made. Namely, of course, there's no sense for a developer of the world's most expensive database system, Oracle, to make MySQL more compatible with Oracle, but that's not a constraint under which MariaDB lives. So to define MariaDB server from a technical perspective, it is a fork of MySQL. So it uses the same standard code base from 10 years ago, and it has then since then diverged. So there's a different set of functionality, and in the very beginning, lots of new work from MySQL flowed into MariaDB. Now if you look at the relative share of new contributions coming to MySQL, very few come from the new contributions coming to MariaDB, very few come from MySQL, so most of them are MariaDB only. So MariaDB has lots of new functionality, and it's not constrained by Oracle DB cannibalization considerations, which means that migration projects are very common where people want to get rid of the cost associated with licenses and other costs of owning Oracle. And there are, particularly in the fintech industry, lots of complete migrations or a number of complete migrations, with a poster child being DBS Bank, Development Bank of Singapore. That's one of Asia's most profitable banks and most high-tech banks when it comes to digitalization. And they have migrated all their 300 or so in-house Oracle applications to MariaDB, and that was done through MariaDB supporting the considerable subset of PLC, well, the stored procedure language of Oracle directly, natively in MariaDB. So then what one needs to know about, from an edge perspective, one needs to know about MariaDB is that it's a general purpose database, hence also very much adjusted for edge. It covers situations with lots of memory and very little memory. So, okay, if you look at relational databases that still are relational databases, but tiny, you would have SQLite, which your phone would likely use. But in and that's because mostly of historic reasons where the first phones didn't have lots of memory. Now it's different. But basically, you can use MariaDB in any general purpose scenario. So it has, and that's because it has something called storage engines, which is something that it has inherited from MySQL, but MySQL has concentrated more on one particular storage engine, InnoDB. And that's an important storage engine, obviously, but it's not the only one. So there's column store for data warehousing applications, and there's somebody here mentioned S3. There's an S3 storage engine, and there's a number of different storage engines that are in memory or somehow specialized for a particular use case. And that is why it is a general purpose database, because it can be adapting the storage layer to the use case, the number of reads or writes, or the number of updates versus inserts. And in the case of Internet of Things, for instance, it's lots of inserts and very seldom updates. And you can optimize that on the storage level, but the top level still has the same syntax. It's the same protocol and it's the same product, in which case you save a lot on the work that you need to learn something, because, and also of course on the tooling around it, which is joined to all of the storage engines. So yeah, and particularly when it comes to edge being mentioned as something that needs lightweight and environmentally friendly and so on, so the number of CPU cycles is lower that a particular operation consumes with MariaDB compared to well, I mentioned Oracle, but a number of other solutions as well. What one needs to know from an organizational perspective, I'm the CEO of the MariaDB Foundation. That's about 10 people spread across the world, mostly in Europe, but also South Africa and Australia. There's also a MariaDB Corporation, and that is the main entity developing new functionality. Our task in the foundation is to keep the code base open so that there are also others, but the main contributor is MariaDB Corporation with 250 people. From an EU perspective, we're all based in the, or not all, but the core part is based in EU, and it's a solution which is independent of big players in America or China or Asia or anywhere. What we're not good at is necessarily navigating EU initiatives in the EU bureaucracy. So yes, I've been fairly often in Brussels, but that's mostly for FOSDEM, the Free and Open Source Developers meeting, not so much visiting the EU Parliament, just a couple of times. And then from a cloud perspective, what's important to know here is that most clouds, all major clouds, include MariaDB in their offering. I mentioned here in the question earlier that the relationship between cloud and free and open source is not always an unproblematic one, and that is why this initiative exists, and Gaia-X and all of that. Based on the licensing scheme, the value created by the software is often exploited by the cloud provider, and the cloud provider is not always giving back any of the value created by the software to the creators of the software. And the provider of MariaDB in the form of MariaDB Corporation has done now the same thing, sort of making sure that there is a feedback loop from the cloud solutions to the software through their offering SkySQL. So that would be, I think, my 10 minutes overview. I'm ready for any questions.
Well, Gaia, I think you've touched on a number of very interesting points there. Well, I was wondering because one of the challenges in terms of mobilizing all this and developing all these edge computing capabilities in Europe is actually to be able to spread kind of a new culture of collaboration among vendors, but also among cloud providers. And that's something, I mean, from your perspective, from the MariaDB Foundation, I guess there's a lot of experience and expertise in how this works out, right? I mean, the way in which you can actually collaborate and create spaces of collaboration between competing companies and in this case cloud providers. How do you see that happening in Europe? Do you see there is the necessary foundations for that kind of approach? There's some needs to be more didactic maybe from the open source community as well.
Yes, so from our perspective, the MariaDB Foundation, we exist for doing three things for MariaDB: openness, adoption, and continuity. With openness meaning that the database is growing through contributions from various developers, and that these contributions are entered on technical merit and not like financial merit. And adoption, making sure that the database is used wherever it's applicable, all over the place, including the cloud and in Europe. And continuity, so that in any scenario involving the MariaDB Corporation, those who have put their investment into the MariaDB server technology will be safe. So your question about how this is working out in Europe and how the collaboration happens between, shall we say, competitors even, and in the area of the cloud. So in our case, we have a number of sponsors for the foundation. Of course, 10 people need to be fed somehow, so we do live off sponsorship. And several of them are active in the cloud arena. And those would include American and Asian cloud contributors or cloud providers, and that of course is a great way for them to support the development and existence and openness of MariaDB server. But I haven't seen much of that activity in Europe. Perhaps I have to take the blame myself for not being able to navigate Gaia-X. When I first saw the presentations by the Bruno Mars and Peter Altmaier, I was truly impressed, and the European in me was happy to see technology-wise interesting things happening. but the number of meetings there was so high that we didn't really find how to productively contribute from our side. So I'm not all that positive or happy, or shall we say, from a European perspective. I think we could do a lot better in providing proper technology to be easily accessed by all the initiatives. We are not in the foundation in such a position that we can put lots of effort and money into navigating these structures. We would need help and guidance. But then I think the technology, the good part with MariaDB servers, that the technology is there and it is open source and it's tried and trusted and it can grow. It's merely a matter of, shall we say, administration to get it to the right place.
Okay. Yeah. I mean, I think there are projects, and there are different projects and different scales and different dimensions, and I think there will be room for. I mean, we hope as well that there will be room for different kinds of collaborations and different kinds of projects of different sizes to unfold and develop this year, and hopefully, as it seems, there will be also support from the European Commission to this kind of initiative. So not just for the big, massive ones with billions of euros, but also for the slightly smaller ones. Okay. Well, Kai, I know you've got a meeting now at 10, so
yes.
Again, thank you very much for joining us. And
thank you, Alberto.
And for the attendees, yeah, feel free to send your questions, and I'm sure Kai will deal with them later on. Thanks. You, Kai. See you around. Okay. Next speaker is Tino, right?
Yep.
Have we met before?
Yeah, a few years back.
Okay, floor is yours then.
Thank you. Let me share my screen. Okay, I hope you can see my slides.
Yes.
Maybe I'm sharing some other desktop.
No, it works fine.
Yeah, okay. Okay, so good morning, everyone. Thanks a lot for attending this webinar. I'm going to introduce a bit of OpenNebula in case some of the attendees are not familiar with it, and also our work in the latest months and even years on how we are using OpenNebula to create this platform to deliver applications at the edge. Okay, so I'm Tino Vázquez. I'm mainly leading the engineering team at OpenNebula Systems, and I'm also the project coordinator of ONEedge. So ONEedge, it's European Union funded project, part of the Horizon 2020 Research and Innovation Program. And in the context of ONEedge, we are creating a next generation edge cloud platform based on OpenNebula. So I'll start by introducing OpenNebula, and then we'll go a bit more on details on how we are creating this edge cloud platform of it. Okay, so OpenNebula, it's an open source project based on the Apache 2 open source license, and it's a piece of software that lets you create private clouds using the resources in your data center. So it also it's able to manage resources in the public cloud and in the edge as of lately. And once you create this cloud based on OpenNebula, you're able to run different workloads on it. So you can run virtual machines, also application and system containers, and also Kubernetes clusters on top of your OpenNebula cloud. So getting a bit in the details of the technologies that OpenNebula uses. So it can manage VMware clusters and run virtual machines on top. And it can also use open source hypervisors like KVM, Picracker to create virtual machines and micro virtual machines, and also LXC for system containers. So this is for the virtualization technology, but it also uses other data center resources like storage resources and networking resources. And storage, you can find plugins for LinStore from LINBIT. So you can build your OpenNebula cloud based on different components from your data center, okay? And on top of that, we offer integration with third-party tools to be able to manage this virtual infrastructure using automation. And also, obviously, graphical user interfaces to interact with the OpenNebula cloud. Okay, so besides the traditional focus of OpenNebula on virtual machines, we also offer the ability to run containers, so application containers on top of OpenNebula. So we have integrations with Docker Hub. So if you start from scratch with an empty OpenNebula installation, you're able to start launching Dockers from Docker Hub directly from the graphical user interface of OpenNebula. It's called Sandstone. And you can also do the same with Kubernetes and also with K3s, which is a more lightweight version of Kubernetes. It's ideal to be run on the edge. Okay, so what's our vision for edge computing using OpenNebula? Okay, so what we created in the context of ONEedge, it's an extension to OpenNebula that's called OneProvision that has its own graphical user interface, which is called FireEdge OneProvision, where you can, starting from a single OpenNebula frontend, so the controller software of OpenNebula that can run off VM in the cloud, or you can run on a server on your core data center. So using this OpenNebula frontend, you're able to grow your OpenNebula cloud using resources from different providers, so public cloud providers and edge providers. So you're able to deploy OpenNebula clusters dynamically and automatically using this tool, and start sending workloads like VM, containers, and Kubernetes to any of these locations, okay? With the added value, and this is where I think our solution stands apart, of not having to convert your workload, but rather, since it's a regular OpenNebula cluster running on a remote provider, you're able to run the same workload that you are running in-house in these edge locations. Okay, so using the same technology, for instance, someone that wants to create a service, an edge as a service portal, can use resources from different cloud providers, also from providers that within Gaia-X. That's our goal as well. So you can aggregate these different providers and create an offering for your end users to consume these different providers from a single pane of glass, which in this case would be OpenNebula. Okay, so a bit on our company. So we are a European-based company with headquarters in Madrid. We go way back from 2008. It was the first technology preview, and it's the only infrastructure as a service open source solution that emerged from European funding for research programs and innovation. So we were funded by different EU projects. Now we are with this ONEedge initiative. We are members of different European initiatives, including Gaia-X. And we have somewhat international location, so we have offices in different parts of the world, and we offer service to all countries. Have a 24/7 support team. A bit on who is using OpenNebula. So we've been around for quite a while, so we have users and customers from different industry niches. We are an active open source project, and we see widespread adoption with downloads every day. We have large deployments. Probably the largest one is spanning across 16 different data centers and offers an OpenNebula cloud that combines over 300,000 cores. Sorry. A bit on our services. So OpenNebula systems focus on giving services around OpenNebula production deployments. So our core item in the portfolio is the support subscriptions, and we also offer professional service around these support subscriptions, like training and consulting and engineering. Okay, so all this new functionality around Edge platforms, so the ability to grow your OpenNebula cloud using Edge cloud providers, has made its debut in the latest OpenNebula release, that's 6.0 Mutara. We worked hard on the onboarding phase of the documentation. So we have a brand new quick start guide where if you are using VMware infrastructures, you can download V1 Cloud, which is an OVA file, and start trying out OpenNebula in a sandbox environment. Or if you are interested in running it in KVM, you can use Mini1, which is a nifty script that deploys OpenNebula for you, also in a sandbox environment, so you can try out the features. So if you haven't done so, I invite you to go to this landing page, OpenNebula.io Mutara, and start learning the basics and playing with OpenNebula. Okay, and I leave you with some resources to better understand the approach of OpenNebula in this new Edge paradigm, and also to learn a bit more on FireEdge One Provision, which is the tool that we use to implement these Edge platforms. Okay, I think that's all I have for today. Let me check the chat to see if there's any questions. I have to say,
I'm still really impressed by the timing. We are all managing.
Thank you. Yeah, it wasn't on purpose.
I know.
Okay, let me see.
I think I have a couple of questions.
Okay.
I know the answers, but I think they might be useful for
okay. Let's see if I know them.
Okay. So so about the catalog providers, that's an interesting tool, right? How is that being integrated with cloud and edge providers? So it's we support some providers now, but there are some on the queue, right?
Yeah, absolutely. So so this is an ongoing process. We want to build a strong and robust and plentiful catalog of providers for building these OpenNebula clouds in the edge. So we started with some de facto standards like AWS. So you're able to use EC2 bare metal instances to grow your OpenNebula cloud. We also offer Equinix to also build your edge clouds. of OpenNebula on those data centers. And we are working in the pipeline for 602 still this week. We'll have also providers for a new a small provider called Vultr, and also for Microsoft Azure. We are working on creating this ecosystem of providers. So we have a process to onboard new providers. They need to contribute a set of drivers and also to maintain them. We also, our team is working on adding new providers, and we also in talks with people from Gaia-X to make their catalog compatible with our tool, so we can consume also this kind of providers. So this is our focus right now. We want to build this provider ecosystem, and hopefully you'll be able to grow your OpenNebula cloud using any kind of cloud and edge provider offering.
So in that, I mean, in that sense, that answers that question, the original question, right, about the avoiding locking in some sense. Right? Yeah. Apply to cloud providers.
Yeah, exactly. I mean, our approach, as I mentioned before, is that we offer, the ability to move your workload across different clouds, because they will be compatible with any provider that has a bare metal offering. And even virtual offering, depending on your type of workload. But this, I think, also it's an argument against vendor locking, in this case, cloud provider vendor locking.
Okay, well, thanks a lot, Tino.
Thank you.
I'm going to use the, you've already mentioned K3S, and we've seen some references to ranges, so that's perfect. Connection with our last speaker, Gerald. So thank you very much for joining us.
Hey, good morning.
Let me to take over. Yep. And share your screen directly.
Here we go. It works. Yeah. thanks for the references. So let's dive in immediately, really quickly. We are a couple of heads. One is I'm CTO at SUSE, but I'm also engaged with the OpenSUSE project, and I'm the chair of the board there. And I found it really interesting how as we talked about edge, because I think there is a little, sometimes there's a little bit of unclarity what edge means. And so I have this little depiction of the different kinds of edge. There is usually, I think, when we talk about edge, we think about what on this slide is called the far edge. That's usually comes with bandwidth restrictions, larger numbers, and it's the typical, retail, hospitality. You have cash registers, you have devices, cameras, and usually lots and lots of them. There is also the concept of a near edge in telco. That's essentially between on-premise and the far edge. And last but not least, the tiny edge, where you have sometimes literally hundreds of thousands or millions of devices. And the reason I figured I'd include this here is, I think it was you, Alberto, who said earlier, this is edge, but in terms of large deployments. And I think edge and large deployments aren't necessarily conflicting. You can have large deployments. You can have massive amounts of storage, for example, on the edge. If you do, surveillance, reconnaissance, drilling, wherever you have low bandwidth, you may need a lot of intake of data, need to store it safely, and then when you're connected better, then process the data and upload it. And so I could well imagine Philipp's solutions, for example, to be part of an oil vessel somewhere in a little edge data center. In terms of attributes, if you look at what are typical attributes we're seeing on the edge, and you will recognize that slide probably. I took the liberty to use the images and titles from Daniel, who was a little bit earlier in creating his slides than I was. So all the attributes that Daniel presented are applicable for Edge 2. In addition, I wanted to highlight a couple. When we talk about tiny footprint, despite or enterprise grade, that implies ARM 64-bit, maybe even 32-bit, x86. And when we talk about mission critical, the mission critical aspect that Daniel had is, I immediately think of security, trust management. When you start your workloads, can you trust the hardware? Can you trust the hypervisor? Can you trust the VM? Can you trust the container? And obviously having all of that highly available. The interesting part with Edge is, or one thing that I found is a little tricky sometimes is, as a developer, how do you get a feel for the Edge? It's a little bit similar to, as a developer, how do you get a feel for a supercomputer? Because more likely than not, you don't have one in your basement. Edge, okay, you may have cell phones, you may have small devices. And for me, the answer to that is making the environment that you as a developer use as similar as possible to the environment that is deployed. So when you develop software and you run it on your notebook and you test it on your little server, your workstation, maybe in the cloud, let's minimize the differences. Let's minimize the differences between where you develop, where you test, and where you deploy, because that minimizes then the chance that along the path something is going wrong. And last but not least, and that's definitely a change over the last few years. When we talk Edge, more and more we talk containers. Like a few years ago, there was more embedded operating systems. Then Linux came, and Linux is now on most cell phones. And if you look at free and open source software, even iOS is largely based on open source. But really, containers is the new model. And that brings some challenges, because container software is a little bit different. It brings many advantages, which is why we're using it. But it also brings some challenges because it's developed differently. You have microservices. So questions like scale, life cycle, and how do you get that under control via automation become more and more critical. And when I say life cycle here, that's a different kind of life cycle in many cases than the one Daniel referred to, the 15, 20 years of having a solution out. That is totally the case. But many then of the containers may actually live a second, a minute, an hour, or a day, because for every user logging into device, for every interaction, there may be a container being spun up and then destroyed again, spun up and destroyed again. So how do you get that under control and in form factors that is suitable for tiny and far edge? And one way to do that is, and to combine all those characteristics I try to depict, is taking Kubernetes, but making it small. And I will admit, I never really installed and played with Kubernetes in the past because it's just a little complicated, resource hungry. But preparing for this, I actually gave it a try, and I did it using K3s. K3s, as Tino mentioned, is Kubernetes, but it's really comes in a smaller form factor. And so this is how you can actually download it. And I did run this on my notebook, in fact, 2 days ago as I prepared for this. And then you actually have Kubernetes installed. And if you see here, K3S on my disk, that's x86 64, just brings in 47 megabyte. But it's a real thing. So it brings tools like kubectl, and you can use it like you would use a regular Kubernetes cluster. Now, one of the challenges, as I mentioned, is how do you scale that? That's also something we have been looking into, and there's different ways. When you have one node clusters, it's not really, Philipp, don't beat me up. I understand that a one node cluster is not a cluster in the high availability sense, but in the Kubernetes world, that's a thing for some use cases. And so when we have a one node cluster, that's manageable. 10 is manageable. But if you have hundreds, thousands, actually up to 1 million, how do you go about that? And that's where there is an open source project by the name of Fleet that we have been engaging with. And we made this part of Rancher, which is management for any certified Kubernetes distribution. And there are different ways. I mean, obviously, OpenNebula is a way. The question just to look at that is, what's the range of scale? You know, what's the scale in terms of systems you can scale to? You know, how many clusters, how many cluster groups, and how manageable is that for you as an individual? Can you do that via APIs? Can you do that via DevOps or GitOps approaches, etc.? And again, the limit right now is in the order of 1 million Kubernetes clusters. And going back to, I think it was Marco on the chat, you asked the question about lock-in and open source. And I think that's a very good question, because I will argue you can be locked in with open source. I mean, extreme case, you contract a vendor, they develop software for you. It comes under the GPL, so they provide you the source code too. That vendor goes out of the business and you're the only customer. Technically, you're not locked in because you have the source code, but it becomes very, very expensive then for you to assume that. And so there's 2 recommendations I would make when you look at open source. One of them is make it modular. So don't go for this monolithic. Don't go for anything that's monolithic. And I would say good open source and companies that have experience do that by definition. And if you look at the charts we have seen from Tino about OpenNebula or from Philipp about what they are doing, it's very evident. This is not one holistic, I mean, it's holistic, but it's not one monolithic stack. It's comprised of many, many components, all of which are open source. And then you bind it together. So that's one way to avoid lock-in. The other one is make sure you're not alone. And what I mean by that is, even if a project takes a different turn, you know, is acquired, MariaDB comes out of such an event, if there are sufficiently many users, and it can be commercial, but also free users, that will then support a plan B in terms of other vendors, in terms of communities. So I would argue, whenever you look for open source, make sure what you pick. And obviously there is always is a user one, a customer one. But if you're not that, then have a look that there is more choice. And modularity, picking one, but not necessarily others, as we have it here with SliMicro, K3S, and Rancher, for example, and not being the only customer. This is a tip of the hat to our colleagues from OpenNebula. I figured I show a nice image of Nebula, but there's also practical relevance in that Kubernetes is actually going to space. There's a company called Hypergiant, and they're using small ARM devices, Raspberry Pis, to power satellites. And every satellite has, I believe, 2 Kubernetes clusters running on those Raspberry Pis, so that they can do failover. Obviously, bandwidth, power, etc., is really restricted there, but they are using K3s. So Kubernetes and K3s are actually making their way into space right now, restrained our solar system. But maybe at one point they'll move away. Yeah, and with that, I hope that was a useful overview over edge and ways to look at that, but also gives you a little bit idea about K3s specifically. In case you're interested, you want to run those commands that I showed and play a little bit with it. Here is the URL, k3s.io, and there is a nice box there. And if you want, you can have a Kubernetes cluster running on your notebook in like 5 minutes. Thank you.
Well, thanks a lot, Gerald. Again, I mean, you've touched on a number of very interesting, very relevant stuff. Well, we have our own experience with K3s, but also Philipp, if you want to, you guys have also been working on tight closer integration with K3s as well, right?
Yeah, but from the storage integration point of view, there is no difference between K3s and K8s Kubernetes.
Mm-hmm. Yeah, but I mean, for us, we've been we found it really, interesting as a concept. We've actually we support our own virtual appliance for K3s, so for users of OpenNebula, for them to be able to deploy K3s on their clouds very quickly. And also, I think the latest version comes with self-registration with Ranger as well. Because Fleet, we had already identified Fleet as something that's has a huge potential in terms of managing large-scale deployments at the edge. And I think, Gerald, one of the things you said was very relevant as well when you mentioned about this granularity of the edge, right? So the different scales, and we call them. We make the difference between public edge providers, like something that's companies and providers that offer a kind of smaller mini data centers in specific occasions, and then obviously the far edge or the on-prem, when that involves IoT manufacturers as well, and a number of devices. And then, as you mentioned that the number of devices just explodes and grows exponentially. I wanted to ask you about the, it's a bit of gossiping, but we're not very used in Europe to see European tech companies acquiring American tech companies. So how is the process going with Ranger Labs?
Well, as you can see, actually quite well. And it's actually not so much European versus US versus any, obviously every company has headquarters, but in my experience, in particular with open source, I've been working with people. SUSE doesn't pay me to develop, but I've been doing this for more than 20 years. And I've been working with people who I've never met. I don't know their age, I don't know their color of skin, I don't know their color of hair, if they have any, or whether they have any. And so it's really less about where people are and what color the passport is. I think there's a certain ethos, if you want to call it like that, around open source, and there's certain ways to think, there is, call it the collaboration gene, and so in the case of SUSE and Ranger, very different businesses, many things we did very different, but there's also lots of things, you have the conversations like, oh yeah, we solved it this way, we solved it that way, and you learn and you connect. So probably a lot easier for two open source companies to come together than if if you're acquired by a proprietary company or the other way around.
Okay, yeah, that makes sense. Yeah, and I mean, actually, I think this webinar is also an example of that, right? I mean, how you see it's been surprisingly easy to organize a webinar with all of you, and I think that also comes down to the fact that we are all open source projects and technologies, right? Okay, well, we're 5 minutes late, but I think we can all live with that. Oh, there's actually a question, right? From Marco, yeah. The EU Commission Compass, I guess you mean the digital compass, right? Launched the plan of deployment thousands of nodes for Edge Cloud Network. Is it clear who's going to be responsible for the choice of technical solutions and overall coordination? How is it going to work? I know if any of you have any more details on this. From my perspective, I don't think the Commission. I think the Commission states that they expect this 10,000. They hope this 10,000 Edge nodes will be deployed across Europe by 2030. What I assume is that what they mean is they expect companies and different organizations to get involved in putting this infrastructure in place, not as kind of a centralized effort, but as a kind of an aggregation of efforts from different companies and providers, existing providers and new providers as well, to create and deploy this new Edge infrastructure and make that available to businesses in Europe and to governments and citizens in the end. So I don't think there's going to be a centralized, I mean, that's how I take it. I don't think it's going to be a centralized effort or some massive funding for this specific deployment, but it's more likely going to be an effort to encourage people and investors and companies to set up those nodes. That's how I take it anyway. But let's see how that unfolds. But yeah, in any case, there will be, and that's also one of the challenges we face, and we hope, I guess, we'll all be able to collaborate in this to provide some solution based on open source, a platform that can speed up this process. So hopefully, by combining a number of open source technologies, we could come up with a solution that helps these new providers to deploy this infrastructure quicker based on open source. So that's my hope, at least. Okay, well, I think we can call it a morning, right? Well, thank you all very much to the speakers, obviously, for making it this early in the morning, and then to all the attendees. And yeah, the promise is that we'll keep working on a closer integration with our technologies and to develop this approach to the edge, also from our perspective as European technologies, open source technologies. So, yep, thank you everyone, and yeah, we'll be around. So anything you need, just let us know. Well, thank you everyone.
Thank you.
See you soon.
Thank you.
Have a nice day. Bye bye.
Thank you. Bye bye.